This is going to go over calculating CIGX, nominal GDP, real GDP, and our growth rate. So we're going to be using some equations here to calculate these numbers. So let's start first by calculating CIGX. So this is our expenditure approach to GDP. So remember, that's consumer spending plus investment spending plus government spending plus our exports minus our imports, or the net exports. So let's go ahead and pause, and let's see what you get for our CIGX equation. So if we go ahead and pull our numbers here, consumer spending is 1,000, investment spending is 200, plus our government spending of 500, plus our exports, which is 50, minus our imports of 75. So the number we don't use here is transfer payments. That's a distractor. So if we add these numbers together, we should get 1675, and that is how you calculate CIGX. Now let's look at calculating nominal GDP. So our equation for nominal GDP is price times quantity. That is our equation for calculating nominal GDP, is price times quantity. So if we want to look for the nominal GDP for year one, it's just price times quantity. So we're just going to focus on year one here, just this row. We're not going to look at any of the other rows. It's price times quantity. So the price of earbuds times the quantity of earbuds. So 40 times 100 plus 1 times 200 for the lemons. And then for watches is 80 times 10. And then we just multiply and add those together, and you should get 5,000. So go ahead and pause the video and figure out the nominal GDP for years 2 and 3. So let's check your answer for year 2. So for year 2, it's going to be 45 times 110 plus 1 times 216 plus 82 times 12, which will equal 6150. And then year 3 would be 45 times 110 plus 1 times 220 plus 85 times 12 will equal 6190. So those are the nominal GDPs for this nation here. So just price times quantity is how you figure out the nominal GDP. Now let's calculate the real GDP. So the real GDP is the base year price times the current year quantity. So it's our base year price times our current year quantity. So if we focus on calculating the real GDP for year 1, what do you think our real GDP for year 1 is going to be? Well, it should be the same as our nominal GDP, because it's going to be 40 times 100 plus 1 times 200 plus 80 times 10, which equals 500. So this is going to be the same as the nominal GDP. Now let's figure out the real GDP for year 2. So this is where we need to find our base year. So our base year is going to be year 1 here. So it's the base year price times the current year quantity. So it's going to be 40 times 110 plus 1 times 216 plus 80 times 12. So it's the base year price times the current year quantity. It's the base year price times the current year quantity. It's the base year price times the current year quantity. So if we multiply and add those together, we will get 5576. So go ahead and pause and figure out the real GDP for year 3. All right, let's check your answers for year 3. So remember, base year is year 1. So it's the base year price times the current year quantity. Base year price times the current year quantity. Base year price times current year quantity. So it's 40 times 110 plus 1 times 220 plus 80 times 12. And that will equal 5580. So that's how you calculate real GDP. Base year price times the current year quantity is our equation for real GDP. Now, if we compare these numbers, 5,000 to 5576 to 5580, we do see growth in these real GDPs. They increase constantly. But if we compare them to our nominal GDPs, does that growth look the same? No. From 5,000 to 6,150, that's that's a bigger difference than the 5,000 to 5,576. So that's why we use real GDP to calculate growth, because this is more accurate than our nominal GDP growth. So let's see what our growth rates are with our nominal GDPs and our real GDPs here, and see if that statement that we just made is accurate. So our growth rate equation is just percent change. So it's just our percent change equation. So it's new minus old over old times 100. That's percent change for us non-math people. If you are a math person, feel free to put the ones and the twos in there. But for us non-math people, it's new minus old over old times 100. So if we want to figure out the growth rate between years 1 and year 2, with our nominal GDP, it's going to be new, so 6,150, minus the old of 5,000 over 5,000 times 100. So if we put that in our calculator, what do we get? We get 0.23, and that as a percent is going to be a 23% increase. Very important we have increase in here. We don't want to leave that word out. And then let's figure out the percent change from 2 to 3. So again, it's new minus old over old times 100. So new is 6,190 minus old of 6,150 over the old 6,150 times 100 is 0.006, which gives us 0.6% increase. It's again very important. We need to have increase in there. So let's go ahead and do the same for our real GDPs. Let's see if our percent changes, our growth rates are the same here. So we'll do year 1 to year 2. So it's new, which is 5,576 minus the old of 5,000 over 5,000 times 100. And what does that give us? $11.5% increase. And then let's go ahead and do year 2 to year 3. So new is 5,580 minus the old of 5,576 over 5,576 times 100. And what does that give us? .07% increase. So if we compare these growth rates, here's our nominal growth rates, and here are the real growth rates. So they're both increasing, so that's good. We didn't have any false growth. But if we compare our actual percent increases, 23 to 11.5, that's very different. And then 0.6 to 0.07, that's also very different. So our real growth rates are a lot lower than the nominal growth rates. So what we can say from these extreme differences in the growth rate is that there's a lot of inflation happening here in these nominal GDP changes. So go ahead and pause the video and you're going to practice on your own calculating nominal GDP and real GDP and growth rate. And then you'll hit play when you're done and you can check your answer. So let's check your answers here. So the nominal GDP for year 2 is going to be $270. So again, nominal GDP is the price times quantity. So we're just looking at year 2. So it's 25 times 2. This should be a 2. Plus 20 plus 6 plus 25 times 4 will get us 270. Calculate the real GDP for year 2 using year 1 as the base year. So we're using our year 1 base year price times our year 2 quantity. So it's 25 times 1, 20 times 3, 25 times 4 gives us 185. And then calculate the real GDP for year 1. So the real GDP for year 1 is our year 1 quantity times our year 1 price. So it's 20 times 1 plus 30 times 3 plus 10 times 4, which gives us 150. And then our percent change, or the growth rate from year 1 to year 2, well, it's new minus old over old times 100. So 185 is our year 2 real GDP. Year 1 real GDP is 150. So I'll give us a 23% increase.